let's talk about the impact of structure on acid strength. And let's begin with binary acids. So binary acids are ones that we see here, where we have H's bonded to a single atom on our periodic table. And what we see is that as we increase electronegativity, we increase acidity. So for instance, fluorine is more electronegative than oxygen, and thus going from H2O to HF, we increase the acidity. In addition, as we decrease the bond strength, in other words, as our atoms get bigger, okay, our binary atoms get bigger, then we gain strength in acidity. So in other words, H2Te with a relatively weak H and Te bond is going to be a much stronger acid than the OH bond, because O is such a small electronegative atom that it holds on to that H very tightly. So to summarize, the more polarized the bond, the more acidic the bond, okay? So HF is more polar than OH bonds, so therefore this is a stronger acid. In addition, the stronger the HX bond, the weaker the acid. HF is a much stronger bond than HCl, so HCl is a stronger acid than HF. Binary acid strength increases to right across a period. And so as we go from carbon to nitrogen to oxygen to fluorine, we are increasing the acidity. And it goes down as it increases as we go down a column. So HF is a weaker acid than HCl, is a weaker acid than HBr, is a weaker acid than HI. HI, HBr, and HCl are all strong acids though. So, to review, the relationship between bond strength and acidity. The higher our bond energy, the weaker the acid, okay? As we decrease bond energy, we get stronger acids. Now let's talk about the strength of oxyacids. Oxyacids are things like H2SO4 and H2CO3 and H3PO4, all of the oxyanion acids, okay? So our H's are bonded to oxygens in our oxyacids, which are bonded to some other atom. So for instance, here we have HClO. This string of letters is actually somewhat misleading, as the H is bonded to the oxygen in this acid. One rule of thumb is whatever our other atom is besides the oxygen, the more electronegative it is, the stronger the oxyacid. So for instance, HClO and HIO, Cl is a more electronegative atom than iodine. So therefore, HClO is a stronger acid than HIO. The acidity of oxyacid decreases down a group, okay? Which is not the same trend as binary acids. I don't know why that says that. I apologize. So as we go down the group and the Y atom becomes less electronegative, it weakens the OH bond and we get stronger acids. Also, the larger the oxidation number of the central atom, now if you recall back from the first semester, we learned a little bit about oxidation numbers of central atoms. But what we might say is this: as we go right across the period, we get higher acidity oxyacids. So in other words, the hydrogen carbonate is a stronger acid than hydrogen borate because carbon is farther to the right than boron, okay? And if we kept going, nitric acid with nitrogen here instead of carbon is a stronger oxyacid than the carbonate acid, okay? Again, also, the more oxygens attached to the central atom, the stronger the oxyacid. So HClO3 has more oxygens attached to the chlorine, therefore it is a stronger acid than HClO2. So to give you a glimpse, if we have these three oxo acids, as we look at the electronegativity, okay, the Ka gets larger as the electronegativity of this atom gets larger, okay? And here's how the oxygen trend goes. As we have more oxygens around our central atom, we have a stronger oxyacid. So, question, what's the strongest acid? Go. The answer for the strongest acid is hydrogen iodide. Why? Because it is both farthest to the right, or towards our noble gas side, okay, and it is the farthest down the periodic table than any of our other acids in that list, okay? That's it.